Hey everyone, welcome back. This is video 4 in organic, and what I want to do in this video is just do some examples and allow you to kind of see the way to think through naming. So again, it's going to be a little taxing, a little nerve-wracking for you when you first do this, but think about how much fun it could possibly be, and just learn what you can. Let's start with number 3 here on the screen. It says, how many hydrogen atoms will be found in an alkane that has 25 carbon atoms? Well, the thing that I want you to remember is, what does it mean to be an alkane? It means to be saturated. And so we had a little generic formula that said Cn, if you're saturated, you will always have 2n plus 2 number of hydrogens if you're an alkane. So if that's the case, this is going to be C25, and then do the math, 50 plus 2, C25, H52. All right, now number 4, we're going to name some hydrocarbons. Now this is going to look a little weird, but I did it on purpose. I just kind of want us to think about some things. Here we see that it is all single bonds, nothing but hydrogen, so this is going to be just a very simple alkane. All we need to do is count the carbons, 1, 2, 3, 4, no tricks. So this is going to be a buta alkane, so it's just going to be very simply butane. Cool. All right, so B is going to be a little bit trickier. I want you to hit pause and just do your best, see what you can name B, and then when you're ready, hit play and I'll go through how to name it. As we look at it, the most important thing to get is that longest continuous chain. So let's count before I start numbering. Possibly 1, 2, 3, 4, 5, 6. Okay, or I could go 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6 that way. It looks like no matter what, 6 is the longest thing I can make. So this is going to be a hex. There's all single bonds here, no doubles. So this is going to be a hexane. Now, what are we going to do with all these branches? We need a number so we can start identifying where these branches are. So our options are for this 6 carbons is go left to right, 1, 2, 3, 4, 5, 6. If I do that, the methyl's on a 2, the ethyl's on a 4, and this one's on a 5. Or if I go the other way, the methyl's on a 2, a 3, and a 5. So it doesn't make a lot of difference either way. Your ethyl is going to be on a 4 or a 3. So kind of the best thing to do here is go left to right where it's 1, 2, 3, 4, 5. That way we got a 2, a 3, and a 5 as opposed to a 2, a 4, and a 5. See how that works? So this will be carbon 1, 2, 3, 4, and 5. All right, what are my substituted groups? Well, we have this, which is an ethyl. Remember, alphabetical order is important, so ethyl. And then I have a methyl here and a methyl there. Starts with the N. So let's go ahead with that ethyl. We know it goes first. So this is going to be an ethyl. What carbon's it on? It's on 3. So this is going to be a 3 ethyl. All right, what about my methyl? I have 2 of them. So what do we learn we did in covalent when we have 2 of something? We go back to those prefixes, and I actually have a dimethyl. And they're going to be on carbons 2 and 5. And we're going to, instead of just saying methyl, we're going to say dimethyl. While I'm writing that out, I want you to notice that we have, if I have 2 substituted groups, I have to have 2 numbers. Even if they were the same, I would have to have 2,2-dimethyl. So we have numbers for every group, and then the prefix to tell me how many. So it's a little repetitive there. And then we said this is 6, so that's going to be a hexane. 3-ethyl, 2,5-dimethyl hexane. Isn't that fun? All right, see, this one's a little easier. It's an alkane, but it's substituted. It's not methane. If this were hydrogen, this would be methane. So we have a variation of methane. All we need to do is identify what that group is. It's bromine, so we just call that bromo. Bromo, and then the rest of the molecule is the one carbon methane, bromomethane. Not too bad at all. All right, D, again, won't you hit pause and try this one, seeing if you're getting the hang of naming these. All right, let's see if you got it right. So let's identify the longest chain. 1, 2, 3, 4, 5, 6, 7, or I could have gone 7 up here, but let's see if we can go longer a different way. 1, 2, 3, 4, 5, 6. That's not longer. Let's go from the back. 1, 2, 3, 4, 5, 6, 7, 8. Whoa. So it looks like at first glance it's 7, but really the longest chain is going to be that way, going 8. All right, so do we number it starting 1 to 8, or does it start over here going 1 to 8? And the answer you should have picked was starting from here, labeling 1, 2, 3, 4, 5, 6, 7, and 8. We do that to give these groups here the lowest number, 2 and 3, as opposed if we went this way, it would be 6 and 7. That's too high. So this is going to be a bit, all single bonds here, by the way. This is going to be an octane. So let's identify our groups. This is a methyl group, and we know it's on carbon 2, so it's really going to be a 2-methyl. Here we have a chlorine, so like part C, when we have a halogen, it's just going to be a chloro. And we know with the number, it's going to be a 3-chloro. And then what about this group here? What'd you say? How many carbons is this? It's 3, and we know 3 is propyl, so this is propyl, and it's on carbon number 5. 1, 2, 3. Yeah, so that's a propyl group. So in alphabetical order, this is going to be, let me write it all out here. This is going to be 3-chloro. This is a lot to write. 3-chloro. The methyl comes next. 2-methyl. And then we have the... What am I doing? That's ridiculous. All right, let's... I hope you didn't do something that silly. Let me erase that. This is when you wish you could just hit delete, right? All right, so let's go back here. I was in the process of making a huge mistake. For some reason, I made my my chain a substituted group there at the end when I should have been circling this. And that is not a propyl, that is an ethyl. So I apologize for that. This is ethyl, and it's coming off the 5. See? Very easy to make mistakes. So let's put that back together. 3-chloro. And now the ethyl comes first. 5-ethyl. Remember, it's alphabetical order. Now the 2-methyl. And then we said it is an octane. Whew, I made a mess out of that one. Let's move on to E. Hit pause and see if you can name E. Just keep in mind that when you see the parentheses like this, they mean they come off the carbon that it immediately follows. So hit pause and give it a shot. All right, let's see how you did. So we're going to assume when it's written this way in this condensed formula that the carbons are already correctly laid out from left to right. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So we go from 1 to 9. This is going to be a nonane. Now this is very important because it's not just super obvious that this is an alkane, but we have a CH3 on each end. Of course, that has to be an alkane. And if you have a chain, as long as you have CH2s in your chain, then those are okay for alkanes. Now, what about this guy here? This is not a CH2. Well, it would be CH2 if it were not substituted with a methyl. So this is 2 things attached to that carbon there. So that's like a CH2. And so we see that same pattern throughout this. So this is an alkane. My 2 subgroups are 1 and 2. So we're going to have that dimethyl moiety again. Dimethyl. and then we just need to say where they are. We can name it 1 through 9 left to right, or 1 through 9 right to left, and we can see right away that the smaller numbers are going to be right to left. So this is going to be on carbon 3 and carbon 5. So this will be 3,5-dimethyl nonane. All right. So F is a lot of fun. Right away, I see an OH group. So this is going to be an alcohol. Notice how my suffix is going to change now. This is no longer an alkane. Everything else is single-bonded though. So let's find that chain. 1, 2, 3, 4, 5, 6, 7, 8. Can you do better than that? I don't think so. So this is going to be an octa. But is it an ane? No, it's an alcohol. So the suffix, really, we just change it to OL. It's an octanol. Now we do have to say for the OL, where is the alcohol? It's on carbon 3, so it is specifically a 3-octanol. There's lots of different ways to make an octanol. I can have a 1-octanol, which is when it's just a primary alcohol, OH on each end, or I could put it on carbon 2, I could put it on carbon 4. And just looking at symmetry here, I think 4 is the biggest we can do. So it could be a 1, 2, 3, or 4 octanol. Now, what are the other groups? We have these here. Those are all methyls. So this time we're going to have a trimethyl. And we just need to say where they are. And they are on carbon 1, 2, 3, 4, 5, 6. So this is going to be a 4, 5, 6 trimethyl 3-octanol. G is going to go very fast. What is that? I hope you see it. It's benzene. I want you to recognize it just that fast and just that important. Benzene. All right. All right, so H, what type of compound is this? Yes, it's an alcohol. So we only have it branched off one little place here. The rest of the carbon chain is in this pentagon. So this is going to be a penta, not pentane, but a pentanol. And because it's in a closed shape, it is a cyclopentanol. Do I need to put a 1 here? No, again, because if you're in a closed shape and you only have one substituted group, that defaults to carbon 1. And so that is understood to be cyclopentanol or cyclopen-1-pentanol or penta-1-ol. All right, we don't want to stop now. If we go to I, hey, look, we have an alkene this time. We have a double bond. I don't see anything else crazy, so we need to number this. The numbering here is much more specific. Remember, the alkene, the double bond, has to be in the longest chain, and it has to have the smallest numbers. So we're just going to go 1, 2, 3, 4. I can see right away this is the longest chain. So this is going to be a hex, and instead of a hexane, it's going to be a hexene because of the double bond. Where is the double bond? It's on carbon 2, so this is going to be a 2-hexene. And now let's acknowledge the substituted groups. I only really have 2. They're both methyls, and they're both on carbon 4. So this is going to be a 4,4 dimethyl 2-hexene. All right, J. All right, I see something a little different here. I have a functional group. I have oxygen in this compound. Do you recognize this? That is the aldehyde. So this is a little bit more complicated name. It's a little bit more than what I expect you to be able to do right now. Okay, so this is going to be a 1, 2, 3, 4, 5. So the longest chain containing the functional group is penta, and it's not an ol, it's not an ane, it's an aldehyde, so it's pentanal, with one substituted group on carbon 1, 2, 3, 4. So this is going to be 4-methyl pentanal. And boy, did I misspell pentanal. Let's try that again. 4-methyl pentanal. That's much better. So says I. All right, in K, real quickly, do you recognize the functional group? It's a carboxylic acid. So really, to name this, we just need to identify the R group, which is benzene. And we're going to adjust the suffix. Benzene becomes benzoic. And then we just throw acid on there. So benzoic acid. In L, triple bond. So this is going to be an alkyne. Let's count our longest chain. 1, 2, 3, 4. And it doesn't really matter what direction I go from for the alkyne. So this is going to be a 2. And then 4 carbons, buta. So 2-butene. Now, does it matter 1, 2, 3, 4 left to right, or should it be 1, 2, 3, 4 right to left? The answer is right to left. This needs to be carbon 1. And that's because we want to give the chlorine here the lowest number. And so if we do that, it is a 1 chloro 2-butene. All right, M's a little bigger. It's another alkyne. Let's find the longest possible chain. 1, 2, 3, 4, 5, 6, 7, 8. Let's try it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's try another one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That way, those are really our only 2 options because it has to have the triple bond in it. So this is actually definitely going to be a decyne. 10 carbons. All right, what carbon should this be? It's easier on this one because it's very close to the end. It's on carbon 3, so this is a 3-decyne. And we need to identify what this substituted group is. Here, I finally get a chance to do the propyl. That's a propyl group. It's on carbon 5, so that's 5-propyl 3-decyne. All right, you try N. Just hit pause and see what you can get out of that. Now that you've had time, I hope you put down cyclopentene because of the double bond. All right, and then we have just 4 more, and these are the easiest ones on here. We have a benzene molecule with some NO2 groups. This one will blow you away. I'll give you 5 seconds. 1, 2. Oh, most of you are probably already done. This is TNT. Yep, TNT as in dynamite, trinitrotoluene. So look backwards from that. Can you see why it's called trinitro? And then can you see why it ends in toluene? If you think back to our aromatics video, I showed you that one derivative of the benzene was when you substitute 1 hydrogen with a methyl group. So that's the toluene. And then of course we have 3 nitro groups that are attached to the benzene. This is just a substituted benzene molecule. So really TNT is quite simple in terms of what makes it up. So that's TNT. As we move on to P here, do you recognize this molecule? It's a sweet one. Look at some of the functional groups. I have some alcohol, some OH groups. I have here, you recognize that? That's an ether. And I have another ether linkage here. And I guess it's kind of a shame I didn't draw it that well, but this is actually a carboxylic acid group up here. So go ahead and name that in about 3 seconds. All right, let's check your naming. This one is actually sucrose. So yeah, I'm being kind of flippant here. It's a very difficult technical name, but a molecule nonetheless that you're very familiar with. You eat sucrose daily. It's It's two ring molecules connected by an ether. So we have that ether, which when you saw the previous video, you might have thought, well, this is the first time I'm ever seeing that. No, not really. And it's weird. It's not really weird. It's in molecules that you interact with daily. All right, let's move on. All right, here's one molecule that you're probably going to find repellent. I see those benzene rings in there. I see some chloro-substituted methyl groups. So this is, what do you think? All right, did you get this one? It's called DDT, an old pesticide. And the full name of this thing is quite a mouthful. This is dichloro diphenyl trichloro, and what's the longest chain here? It's actually just that. So this is an ethane, believe it or not. Let's break it apart. Why dichloro? Well, chloro. Phenyl. What the heck is phenyl? Well, the benzene group, when it substitutes in for a hydrogen and connects with carbon, those are called phenyl groups. I don't know the origin of phenyl, how benzene becomes phenyl, but it does. So we have dichloro, diphenyl, and then we have this, what would be normally a methyl group. It's triple substituted, so 3 chlorines, trichloro, and then I mentioned the long chain is actually right there, ethane. All right, and then the final one. This one makes me green with envy. A little bit trickier. I'm not going to beat you up too much over this one. This is actually a molecule that's important for life. This is called chlorophyll. Pretty complicated looking molecule, isn't it? Chlorophyll is a group of molecules that are called porphyrins. I believe they're called porphyrins. And the most important thing is the structure, because this is a conjugated structure. That's way beyond what you need to know. I'm just talking to you here. The conjugation means that it's these double bonds that are sort of alternating here lend a lot of stability to this molecule. And it also creates an area here where you have some charge distribution that allows a metal ion to be caught kind of in the middle of this ring. And that's very important, because that ion there becomes a place for electrons to be sunk. So what happens in photosynthesis is that sunlight hits a leaf, it hits this pigment molecule, it excites an electron way out here on the periphery, and that electron migrates toward this positive region in the middle of the molecule, which is a magnesium atom. And that's really it. We can see there's double bonds in this. We can see some substitutions. Here's a CO2. I think that's a carbonyl in the middle of that. So chlorophyll is really quite a complex molecule. All right, I know that's not going to be perfect, so practice makes perfect. In class, you're going to have a chance to name some. You're not going to be an expert at this. You're just not in the time frame that we have. So don't get frustrated. Have as much fun with it as you can, and come ask me questions as they arise.